Hey guys, this section is going to be on arithmetic series, so I wanted to do a quick little review of arithmetic sequences and do a nice little proof of arithmetic series. So here we go. So here's one particular example of arithmetic sequence, and then I'll go more general. So say I had 4, 7, 10, 13, 16. So this is going to be a finite arithmetic sequence, and our difference is going to be 3. We're going to be adding 3 every time. Okay, so in this case, this would be our A1, A2, A3, 4, A5. Ooh, let's write that a little bit better. A5. All right, so another way we could write this is the first term, A1. Let's do pink. A1 could have been just 4. A2 we could have written as 4 plus the difference. The third term we could have written as 4 plus the difference plus the difference. A4 we could have written as 4 plus the difference plus the difference plus the difference. And 5 we could have written as 4 plus the difference plus the difference plus the difference plus the difference. And yeah, let's see. Can we simplify this a little bit better? Can. So we can write this as 4. Yep. 4 plus 1, 4 plus 1 times 3. That could be our A2. Our A3 could be 4 plus 2 times 3. Our A4 could be 4 plus 3 times 3. 4 plus 3 times 3. And then 4 plus 4 times 3. So remember, this would have been our A1, A2, A3, A4, A5. So maybe you can see the pattern already, but again, let's show a little general form here. So say I had, instead of A1, I'll just have A, and then our difference is going to be D. So we write it as A plus D, and then A plus 2D. And then A plus 3D, and so on, so on, so on, until we get to our final term, which would be A plus whatever the amount of terms we're going, which would be n terms, so it would be 1 less than that, times D. Okay, so can you see why this is our formula then? Because it doesn't matter what term we put in there. So say we had A of 6. That would give us our first term plus n, which is 6, minus 1, so 5 terms times the difference. That would be 5 of these. Hence, 19 would have been our A6, which would have been, we would have did 3 plus 3 plus 3 plus 3 plus 3, 5 times. And that's where this formula idea comes from. So this is going to be very important when we're talking arithmetic series. So, an arithmetic series. Here we go. Arithmetic series. An arithmetic series. We're going to notate it as S of n, S being series. So basically what an arithmetic series is we take an arithmetic sequence, whether it's finite or infinite, and we add all the terms together. So let's use our general formula over here. We do A plus A plus D. Let's spread that out a little bit better. A plus D plus A plus 2D plus A plus 3D plus so on, so on, so on, so on. And then what would our final term be again? It would be A plus n minus 1 D. So we would add all those together. That would be an arithmetic series. So the way to prove this, is to set it up in the opposite direction. So let's go back actually. So we got our last term. So our last term is A plus n minus 1 D. What would be the second to last term? Second to last term would be A plus n minus 2D. And then the third to last would be a plus n minus 3d. And then obviously we would have some in between here. Okay, so if we went the other way and we wrote it as the other direction, it'd still be the same thing, right? Because we're adding them all together. So we would get a plus n minus 1d plus a plus n minus 2d plus a all the way at the end. That's going to be a at the end. So let's do a little bit more. So let's get the same thing so you guys can see it. And so we get a plus n minus 3d plus a plus 2d. It doesn't matter how many terms this is. Plus a plus d plus a. Okay. So the way to prove this is, let's say we add these together. So let's add this one with this one. And since they're the same thing, it would just give us 2s of n. All right, think about that for a second. All right, so now if we added these two terms, we would get 2a plus n minus 1d. That would be the first term. The second term would be 2a plus, so now we have, I'm going to bring this to the side a little bit. We get d plus n minus 1d. So I don't know if you remember, but if we have two terms that are the same in a multiplication problem and we're working with an addition, we can factor out a d. And then when we factor out a d, we get 1 plus n minus 1. And what is 1 plus n minus 1? Oops, I forgot my 2a. Oops, I forgot my 2. Sorry, this is supposed to be 2. So that would be 2 as well. Sorry. And then when we get d times n plus 1 minus 2, it's still going to be n minus 1. So we get n minus 1 d. And then if we added these terms, it would give us the same thing. So I'll show you. So if we got our a's, obviously our a's are going to still be the same. A plus a is 2a. And then we get 2d plus n minus 3d. Factor out of d's. We get 2 plus n minus 3, which equals d times n minus 1. Works every time. Cool. So on, so on, so on, so on, so on. And then what? So, if it's always going to be the same thing, then we know we have our constant 2a plus n minus 1 times d, and we would multiply it by how many terms we have. So how many terms do we have? It tells us right here. N terms. So we know that 2s of n equals that whole guy right here. Pretty cool. So now if we're solving for s of n, we know s of n equals n times 2a plus n minus 1 d all over 2. So that is one formula. That is one formula you can use for the series sum of an arithmetic series. Now, we can break that up, and I think it's a little bit easier if you do break it up. So we could write this as s of n, and then if we broke it apart a little bit, we could write it as n times, and the top part here, let's see if I can turn to blue. I can break up the a's, and I get a plus a, right, plus n minus 1 times d, and all of this is all over 2. I don't know if you can see it, but this is pretty cool. So you can see that a is going to be our first term. So we have a. And then we're going to add the last term. This is our last term. Remember? Ooh. This is our last term. This is our last term. So it's our first term plus our last term. So we can write it as a1 first term plus the last term all over 2. That is another formula. So both of these work. And that's pretty cool. Okay.